Okay, we are back with question 2b. So we are still calculating unknown angles in the given diagram. So in 2b, we have this triangle here, JLN. We've got an extension here from L to K. We've also got a line drawn from this point M to O, which creates a little small triangle here, OMN or MNO or MON, however you want to say that. So that's basically, if you analyze this diagram, there's quite a few shapes being formed here. We even find a little quadrilateral here, but don't get along with all the shapes that are coming out of this. You need to just, well, first of all, look at what shapes you can identify and how best to use them. So it helps to, before you jump into equations and calculations and all this stuff, just take a few minutes or a few seconds to look at what it is that you're looking at actually. So we need to find angle X and angle Y. One thing I can pick up here is that this diagram here does not have any parallel lines to it. So we will not be making use of alternate angles and corresponding angles and co-interior angles. So that is out. There's no quadrilaterals here that one can speak of, or properties of such that can help us. Although you could, and that would probably be a longer way of doing things, but you could actually find this value of this angle here and here, and then you would have 1, 2, 3 angles of this quadrilateral, and you could find Y. Or perhaps there is a shorter way, so we'll have a look at that now. If I look at this exterior angle here, angle 70 or 70 degrees, if I look at this angle here, this exterior angle, so this is an exterior angle of this large triangle here, we of course know of the exterior angle of a triangle property, and that would be equal to the sum of the interior opposite angles, or the opposite two interior angles. The opposite two interior angles of this exterior angle is Y and X. Now, that of course does not help you because these are two unknown angles, and we cannot basically use the exterior angle of a triangle property to find the size of X or Y. That just wouldn't work. So if I go into this small triangle where X is located, I can see that there's a given angle of 70. There's a value of X, of course, unknown, and this here is unknown. However, I can see that 110 degrees is adjacent on the straight line with this angle, which means I can find the value of this angle, and that means I can find the value of X within the small triangle. So I think that is the easiest way to go here. So in triangle, I'll call it MNO. So MNO. That was 2B. Okay, so this is B. So I'm just going to say here, in triangle MNO, we have, and here we just need to be careful how we name the angles. I know this is a bit of a sore point for some of you, and because there's nothing here as a label, but we know that this is MON, or if you want to say NOM, but that this angle would be labeled as MON, yeah, or like I said, NOM. We know that this angle, so I will say MON plus 110 degrees is equal to 180 degrees, and the reason is adjacent angles on straight line. Now it's a bit, maybe you might think, well, what I said now, this is not taking place inside triangle MNO. So why did we say inside or in triangle MNO? It was just to point towards this angle here, which can be found inside triangle MON. And by saying inside triangle MON or MNO, I can then just sort of pinpoint this angle here, and that would locate properly. And I'm saying, of course, that this angle plus the one next to it is equal to 180 degrees. And the point here is, of course, to find the value of that angle. So I have here that 180 degrees minus the 110 degrees will, of course, give me the value of MON. And that, of course, will give us, if I take 110 away from 180, I will have 70 degrees. So that means this is 70 degrees, which makes this an isosceles triangle, by the way, which we don't need to annotate that, but yeah, just an observation. So that means that in that same triangle, that x plus 70 degrees, the one here, plus the other one, plus the other 70 degrees, they must all add up to 180 degrees. And that would be sum of interior angles of triangle, what do we call it? MNO. MNO. So MNO, that triangle there. So we are going to add up 70 and 70, and we get 140 degrees is equal to 180. So x is equal to 180 degrees minus 140, and we of course have that is 40 degrees. So x is 40. X is 40. Okay, so now let's just regroup and see how are we going to find the value of y. Where should we start? So y is part of this big triangle here, and currently in this big triangle I've got this angle known. I don't have that one, and I don't have this one, but I can find that one if I wanted to. And of course that means, or what I mean by that is that 70 degrees plus this angle, they are adjacent angles with straight lines, so they must give you 180. So I can find the value of this angle, which means in this big triangle JLN, if I have the value of this angle, I've got this one, I can then find that one. The other route would be to use the exterior angle of the triangle property, because I now have one of those opposite two interior angles, so I can find the other one if I were to use that property. So let's go with the first approach, which is to find this angle here. So that angle is of course called JLN. So that's JLN. So we're going to find JLN. So let's say that 70 degrees, which is the exterior angle here, plus this guy here, so plus JLN is equal to 180 degrees. Reason is adjacent angles on straight line. And then of course we can subtract 70 from both sides, or take the 70 over, becomes minus 70 degrees, so that of course gives us 110 for JLN. So JLN is 110 degrees. So just to again check here, we are working in the big triangle, and we've got this angle's value, we've got that one's value, so we can find y quite easily. So in triangle JLN, I can say that y plus 110 degrees plus 40 degrees equal to 180. Y plus 110 degrees plus 40 degrees is equal to 180 degrees. Reason is sum of interior angles of triangle JLN. Then doing the algebra here, I've got y plus 150 degrees is equal to 180 degrees. So y is equal to 180 degrees minus 150 degrees, and y is then equal to 30. So y is equal to 30. And then we have x and y. Now just to look at the other approach, I'm going to use the exterior angle of a triangle approach. So I can say that I'm going to make a statement that says that 70 degrees, the exterior angle, is equal to y plus 40. So I'm going to write that. So I'm going to make or over here, say that 70 degrees, and the 70 degrees I'm referring to is this one here outside, and that is equal to angle y plus 40 degrees. And the statement that I'm making, the reason for that statement is exterior angle, say exterior angle of triangle JLN. And if I keep my y on this side, I subtract 40 from 70 here, I get y equal to 30 degrees, and that's the same answer. Actually went a whole lot quicker than the previous approach. So you choose which one works better for you, or basically whichever one you noticed first when you analyze this diagram.